So go ahead and compare your answer that you were supposed to finish in our last video to number 6. And then next, I need you guys to again pause the video, and using your unit circle, you are going to fill in these charts. So these are the exact values of sine. So on your unit circle, you would go to 0 degrees and then tell me what the exact value is. So this one would be 1. And sine of 30 degrees is 1/2, and we would keep going. Same thing with cosine. So cosine of 0 is 1. Cosine of 30 is the square root of 3 over 2. And then once you get the chart filled in, you are going to graph your sine function on the first one and the cosine one on the second one. And it's already given you your x scale. And then I'm going to tell you that our y scale is by 1/4 on each of these graphs. And when you go to graph something that looks like this, you would find the decimal approximation. So this would be about 0.87 when you graph it. All right, so again, go ahead and pause the video, fill the chart in, and then get your graphs. Okay. So they should look something like this for each of them. Okay. So anytime we are talking about sine and cosine, this is our starting point for talking about these graphs. Now, as I'm looking at this, if I were to continue my degrees, my y values are going to start to repeat. So this is going to continue this waving pattern for sine and cosine in both directions. So that means that both of these are periodic, and that when we are in degrees, our period would be 360. Okay. Now I could change this to radians, and if I'm doing that, then I'm just using my radian equivalent to the degrees. So at 360, this would be the same thing as 2 pi, 3 pi over 2, pi, pi over 2, and 0. Okay. So if I'm in radians, then for the period, we would say that it is 2 pi, because that's our radian equivalent to 360 degrees. Okay. Now, anytime we see this wave-like pattern, that means that we are dealing with a sine or cosine function. So if it's not this wavy pattern and it looks more like this or like this, even this one's not quite wavy enough because it's coming to more of a peak, that's not a sine or cosine function. But this one would have to be because of that wave pattern. Same thing if we go back and look at our examples for 5 and 6. This is a nice wave pattern, so I know that both of these are dealing with either the sine or cosine function. Now we would need a little bit more information to be able to figure out which one it is and what that equation would be. But for right now, we just need to be able to recognize those waves as either as a sine or cosine function. Okay. Now just to do a little bit of review from earlier in this section, for this graph, if I asked you what the period was, again, you're telling me the length of one of the cycles. So this could be it right here. So if I'm counting the distance from this point to this point, it would be 60. Same thing on this one if I just asked you for the period of this function. I can start here, and then I would follow my curve around to this one. So that length would have to be, let's see here, 180. And then if I asked you what the frequency was on each of these, remember that's just how many times our pattern is showing up. So on number 5, if I'm counting, this would be 1, 2 for my frequency. And then on 6, this would be 1, 2, 3, 4. Okay. Whereas if I go back to these problems, I would have a frequency of 1 on each of those, and the period length would either be 360 or 2 pi. All right, and that's going to conclude this section.